In the last lesson, we looked at modus ponens, and we saw that that's an inference where you have a conditional rule and then a trigger telling you that the sufficient condition is true. And then that allows you to infer that that necessary condition must be true as well. So if A, then B, A, therefore B. Again, this is an MP inference here. We'll just show you one more time. If Jones is going to the party, Sullivan will go too. That's our conditional rule. Here is our trigger that tells us that this sufficient condition is true. So then we're able to infer that Sullivan will go to the party. The necessary condition will occur as well. So that's the modus ponens inference. Now we're going to look at the inference that's maybe not quite as easy to see readily. Modus ponens works in the direction of the arrow. A is true, and then you can conclude that the back end is true as well. The inference that we're looking at now, modus tollens, works in the reverse direction. We're told that B does not occur, not B, and then you can infer that A does not occur either. If A, then B, not B, therefore not A. Let's look at that with our English language example here. Okay, so we have our conditional rule. If Jones is going to the party, Sullivan will go too. But then we get the additional information, this trigger, that Sullivan is not going to the party. This tells us that the necessary condition, this part right here, is not going to occur. And remember that the necessary condition is called necessary because it has to happen if the sufficient condition happens. So if the necessary condition doesn't occur, then it stands to reason that the sufficient condition can't occur either, right? Those two things are connected. So if the necessary condition doesn't occur, there's no way that the sufficient condition can occur. So what we can conclude here is that Jones isn't going to the party either. That sufficient condition must not happen, must not occur, must not be true. So we can infer then that Jones will not go to the party. And if we want to represent that in diagram form, Jones party, then Sullivan party, not Sullivan party. Represent that like this. Remember, it's our negative condition. And then, not Jones party either is our inference down here. So again, this inference works backwards in the direction of the arrow. You get something that negates the necessary condition, and then you're able to tell that the sufficient condition doesn't occur either, becomes negative. Okay, read the text lesson so you can recover this ground, make sure it's really embedded in your brain. Then we'll take a quiz so that you can get some practice with it, and you'll be ready to move on.